Go ahead and get started. I wanted to finish up this topic on remediation before jumping into sort of our malware classification target. Now, as I previously mentioned, we're sort of at the point of the semester. We have effectively covered everything we are required to. We've hit all the required learning outcomes of the course. And so anything we talk about at this point is sort of just nice to cover, extra things to have here. So I'm thankful for those of you who are here and want to learn more about this. Some of it, I think, does come across as an info dump because we're definitely now also getting to the place where you aren't really seeing this specific type of things in the lab. There was that lab on auditing and remediation. There was very little remediation and a relatively small amount of auditing as well. But there's some complexity there. It's one of those things that I think in isolation sounds relatively straightforward. Where we left off last week is we were talking about how, okay, I have a software application or a package, and there's a discovered vulnerability, and then there is a released update or patch for that software. I just go ahead and I install that update, install that release. And probably for your own personal computing equipment, that's a good way to go about it, to follow agreed upon automated updating trends and release schedules and just go with sort of best practices there. The things that may work for your sort of own individual personal computing environment may or may not scale to sort of the organizational side, where maybe it's 200,000 devices that have to be updated, and where it's not just sort of maybe a software monoculture where you just have to update your Ubuntu box and you're done. You could have many, many different types of devices or from products from different software vendors. They're all going to have separate updates and separate update release schedules, and they're also going to have different ways of sort of classifying those updates as well. And that's where sort of a one-size-fits-all solution of I'll just install the updates doesn't necessarily scale to sort of organizational side. Each of those, as I mentioned, have different methods. There's usually some sort of commonality in the release. Not everyone uses the same terminology here. In the Windows world, I used to hear a lot about hot fixes, which was a very small piece of code that was meant to correct sort of a major bug that had to be corrected instantaneously, that could not wait until the next sort of scheduled release. Then you have this concept of just a patch. We looked at a couple patches already, which is usually a more publicly released update to fix a known bug or known vulnerability. Also in the Windows world, you have this concept of a service pack, which is being used less and less, but you still see it in some of the Microsoft documentation. It is kind of a Microsoft specific thing. It's not super technical, it just means you have sort of a cumulative set that have been tested in some organizational way. And so from top to bottom, it's sort of less likely to, or more likely to cause you problems to less likely to cause you problems. In terms of process, how you would do that, again, we talked about how someone who is discovering vulnerabilities or staying up to date on vulnerabilities, depending on the size of the organization, may not be the same people who are in fact going to be the one upgrading or patching those vulnerabilities. But what makes it non-trivial is, again, for your own personal machine, you update. If you break something, so be it. This isn't at all distracting. Okay, thank you for that. Okay, appreciate it. And what can happen that updates will in fact break software that you actually need. And it's not that straightforward to think about, but it does turn out that as you have a software that has a piece of functionality that's going to change, you may then be building upon that prior functionality. Even if it turns out, and it's subtle enough that it's hard to think of a really concrete example of when this would happen in practice, even if that functionality that you were building upon turned out to in fact be a vulnerability, and the fix is to remove that particular piece of functionality that you are dependent on. And so we have to be aware of that you have these patches. It's not as simple as saying deploy to all, install all. You have to test. You have to have some sort of staging area where you can individually test, determine what kind of impact that may have. You may have to have an ability to roll back those tests as well. So it is, although it sounds that way, it's not as straightforward as just saying vulnerability leads to patch, leads to update. Eventually that does need to be the standard kind of flow, but it's not a guaranteed automatic, push the button and work. And what does also complicate that is as you have these different vendors, and this is just some of the major sort of operating system or database level sort of vendors here, but really for every piece of software application or package you're using, they all have their own sort of versioning scheme. It would be very nice if all major software providers followed semantic versioning. You may or may not be aware of, but even if they, that would be nice, that's not really the case. But when we talk about semantic versioning, more likely in sort of the open source software world, you would see this being used. You have this idea where the version of a particular software has a number, dot number, dot number, and maybe that's obvious because we've been talking about and using some examples of semantic versioning all semester long. The first number is the major version, the idea being that you only update that particular number when you make a change that's guaranteed to break some public interface. They use the term API here, that's fine. That your software is going to break software that's dependent on it when you make that change. Not necessarily a bad thing, right? Software has to grow, software has to evolve. You eventually then have to make changes that are going to break existing things. I guess you should do so somewhat cautiously, somewhat carefully. That's what that first number is intended for in the semantic versioning scheme. Then minor version is when you're going to add some functionality that's going to still maintain backwards compatibility. So you're adding a feature, but it doesn't break existing dependencies of your program or programs that are dependent on your program here. Some softwares don't do any minor patching whatsoever, and everything is then effectively a major patch, a major version. And then when you have just those individual bug fixes, those patches, that's when you would modify that third number there. And when you start to look at software you use, you may get a feel for the relative stability of the software. So if you look at a software and it's version 534.0.1, that may tell you that, doesn't mean it's a bad piece of software, but maybe a piece of software you can't rely on to stay stable for a relatively long period of time because they're constantly incrementing that major version and introducing breaking changes. A little bit of irony here. This is just a guide saying when one should do those changes and a little bit of a vision statement for it. This document itself is also versioned. This is version 2.0.0. And if you look at the GitHub issues for this particular document, there's a lot of arguing about what this should be versioned. So the semantic versioning document itself, they can't agree when it was a major change versus a minor change. But we may not necessarily think about that, but all the software we use has some sort of versioning mechanism, by and large. If you're using things built upon major open source software, you're going to see some version of this, if not strictly following it, at least loosely following it. I just looked at just for a piece of software, so Chromium, right? Probably the most complicated piece of software you use, no matter what operating system you're reliant on right now. I guess if you're entirely in the Apple world and never touch upon a non-Apple device, you may not be using the Chromium engine. Open source base for Chrome, which is then the open source base for a lot of other web browsers, which then is the open source base for a lot of web application front ends. And there you can see the versions. This was just a random GitHub page. I'm not sure certainly if that's most up to date. Version 121.0.6141.1. Well, that tells you something, right? That for a given major version, there are a whole lot of patches that have to be provided for Chromium. Probably makes sense. It's probably like the number one major open source target for people looking for vulnerabilities because of the potential impact. If you then take that and look at sort of commercial software that's built off it, here's Google Chrome version 130.0.6723.117. That is a lot of patches and little hot fixes applied on top of that version 130 there. So that's just semantic versioning. Not to say that life is easy if all software was using semantic versioning, but it would give you some level of first guess, knowledge about whether or not an update you were wanting to install was going to break something that is reliant on it in your organization or not. Again, this depends on a level of trust that the software you're using is following things and is being truthful about how they version. But I guess if it was a .0 to a .1, then you can assume, well, it's adding some feature, but it's not going to break anything we're using it for. But that is also assuming that the feature you're using itself wasn't the vulnerability that's getting potentially patched out. Things are definitely different in the Microsoft world. They don't use semantic versioning outside of some open source software that they then release. Microsoft is historically very famous for Patch Tuesday. Second Tuesday of every month is when they bundle all of the existing patches and hot fixes together and push them all out at once. Very peer-to-peer distribution of it now. Organizationally, the organization can decide to hold on deploying those patches until they do their own internal testing. It is an old adage at this point. There's still some validity to it that Patch Tuesday is historically followed by Exploit Wednesday. I was going to ask this on the quiz on Thursday, but I was here. Why would that be the case? Sure.
Because then they know like what the problems are.
Right. When,
You could like
right. The patch itself, whether the binary code that's pushed out as part of the patch is easy to reverse engineer and figure out what exactly it's patching and why, that's not always the case. But the target for those patches is something of a roadmap then, right? If I'm patching this particular version of software and updating it from 128.0.1 to 128.0.2, well, something between that .1 and .2 is the target. And depending on if there's a CVE listed alongside it, or just depending on the release notes for that patch, that gives a little bit of a roadmap for those who are looking to find vulnerabilities. And again, while the patch is released on Tuesday, the big combination of all these patches packed together, they're not necessarily widely deployed by that Tuesday. You will sometimes see these articles that say, well, one really must apply this patch and don't wait for this particular reason because exploits have been seen in the wild. Even if they hadn't been seen in the wild yet, that roadmap is then essentially provided via those patching. And there's really no way to get around that. I patch this piece of software, and if I claim that it's a security patch, if we look at Microsoft's security update guide, they will generally say whether a patch is for security reasons or not. If there is a CVE, they will provide that CVE associated with it as well. Not all CVEs would have a provided proof of concept. Not all of them provide a lot of technical detail as to why it is a CVE in that particular piece of software, but it provides a starting point. And oftentimes with a starting point, people can go and take it to the next level and figure out what is potentially actually exploitable here. So you can look at what a typical Microsoft release guide looks like. Now, we have to separate between sort of some of the applications that they're patching and then just the main OS itself. So they're talking about Microsoft Edge updates. Those are probably just directly tied to the Chromium updates. So you have your semantic version here, and you have the CVEs associated with it here. I may have to scroll down a little bit. I mean, there's going to be a lot of Chromium updates of various types to get something that's not that. I was wanting to look at like core software. So Windows Server 2012 release 2, having some CVE associated with it, some remote code execution in some particular module. That may provide some sort of roadmap to those to try to figure out what is potentially vulnerable in that version of Windows Server. So that's all we mean by that old adage of Patch Tuesday followed by Exploit Wednesday. These things have been announced as potentially vulnerable. Here's the fix for all of them. Those fixes get rolled out at a certain cadence. They're not all instantly kind of applied. And oftentimes on that Patch Tuesday, you'll see various articles written that will kind of attempt to summarize effectively everything that's in this table. So it's the same exact information source for it, but for that particular Patch Tuesday, what exactly got patched and for what reason. And it's kind of interesting, right? I mean, I don't know if you think that based on what we are doing in labs, that these CVEs and these exploits and these patches are all kind of, to some extent, sort of ancient history. Well, it's ancient history, the versions we use sometimes in the lab, because we want something that's kind of well understood, matured, allowed us to kind of roll out a relatively safe way of exploring that particular patch, waiting for kind of open source software to update their definition files to be able to detect and recognize and potentially exploit those vulnerabilities. But in the wild, in the quote unquote real world, Microsoft Patch Tuesday, this article written less than a week ago, just attempts to summarize what a typical Patch Tuesday winds up doing. A lot of that is Chrome. Of course, a lot of that is, or Chromium/Edge. A lot of that is then other sort of maybe slightly more obscure products like SQL Server and things like that. I mean, it's a very large company. They release a lot of software. But in total, of that particular Patch Tuesday, 89 CVEs, 3 of which were publicly disclosed. I guess that means 86 were not previously publicly disclosed, and this is sort of the first disclosure of it. Exploit in the wild, that just means that what was already known and already being exploited, that number only goes up. It can't really go down after that point. The various codes severities, and that's related to like the CVSS scores of those, and then which ones have, for example, remote code execution, 52 of them. So this is from a fairly well-established, maybe most established software company in the world, a product that has been around for many, many, many years, have many thousands of engineers in total working on them, and yet we still see on a month-to-month basis, in this case, 89 CVEs, some of which are already being exploited, others are likely to still be exploited, potentially remote code execution in a large number of them. So again, while in the lab it may seem like, okay, here's this 5-year-old vulnerability with this exploit and it shows up in this scan we're doing, that is just for the nice kind of self-contained lab environment. In practice, this happens every single month on the second Tuesday of that month, and that's just for the Microsoft patch release schedule. All of your other software vendors have their own schedule, their own release lifecycle, and all of those are potentially breaking changes for your existing infrastructure at your organization. And I think unlike some other major OS manufacturers and developers, Windows lifecycle and versioning is a little complicated to follow. They have changed their own lifecycle and versioning guides many times in the past. I was kind of curious what everybody is running in this class. I don't know how many of you are even running Windows in the first place. I actually didn't know what I was running in this class. So they have their own lifecycle and sort of release guide, which is meant for the organizational view of when I install a particular operating system, how long is it going to be supported with updates? How long is it going to be providing other types of contractual support? And at least in the Windows world, it really depends. It tends to be the answer, depending on what operating system we're talking about, depending on what version of that operating system, how long will it be expected that new updates, security and otherwise, will be provided. Sometimes a company like Microsoft will say, well, security updates will provide for 10 years, but actual feature updates will only be 2 to 3 years. That has started to change. There was certainly a period in time where the release of a new Microsoft operating system was a pretty big deal because that's where you would get new features. Now it seems like there's a much more stable kind of major versioning of the operating system where we've been on Windows 10 and Windows 11 for quite some time now, and that appears to be still the plan here. So I had to look it up myself because I certainly didn't know. I'm running effectively the last version of Windows 10 Enterprise on this. So that's not semantic versioning, but that's 2022, second half of 2022, and that happens to be the major and minor versions of that OS particular build. You can't really look at that number and say anything about it other than incrementing means more recent. I'm curious, there's lots of ways you can check. This would just be under Windows settings. Every operating system has its own way. I'll be curious, what is everybody running in class? Anyone know yet? So mine's probably one of the older ones, but I'll be curious, what do we have? We'll start with just Windows for now. It's about half of you.
Windows 11.
Okay, so that's pretty up to date. There must be a 24H1 that's out, but I don't follow you. Just a couple months ago. So 24H2 is the most recent version of it. Part of that I don't personally understand Microsoft and whether it's part of an organizational device. For mine, for example, I don't have control over what version's running on this. It's not my call. When one chooses to go from 23H1 to 24H1, 24H2, do you have to opt into something? Is it something that will automatically happen eventually? Have you been hitting decline for several months in a row? I don't know. Anybody running anything older in here? Everybody's horribly up to date. Okay, excellent. I won't try to exploit your machine. That's the Windows world. One possible takeaway is it's not that straightforward. I don't know how useful of a takeaway that is, but there are major, both the server and sort of enterprise workstation and kind of personal computer versions of the operating system, and you have to kind of keep up to date with what the major versions are and what the implications are for how long such a thing will be supported with updates. Typically, though, Microsoft has changed their mind on that. When there's been a big outcry that Windows 8 was no longer going to be supported, they extended and extended and extended it because they recognize It's not in their best interest to have these kind of unsupported, exploited machines out there in the wild. This is in comparison to kind of the Linux philosophy, where it really does depend on which distribution you are interested in. Ubuntu is probably still the most popular distribution of Linux, depending on how you measure it. It's a variant of a Debian Linux, and there's many, many variants of Debian Linux, and they all use very similar styles of package management. There was a time where people would have loud hallway arguments about which version of Linux is the most important one to use for this or that purpose. I think perhaps I've just gotten older. I think the world has kind of matured and recognized. First off, they're all probably pretty good, and whatever you need to use to get the job done. Sometimes the trade-off is between sort of individual user usability and sort of supportability at an organizational level. And that's why, for example, in our department, we still use Red Hat for all of our Linux machines, even though it's not very pleasant developer experience on Red Hat. This is kind of a different sort of comparison to sort of the Windows philosophy of releases and versioning of it. For just historical reasons. They also have sort of effectively a 6-month cadence of releases of Ubuntu. 3 out of every 4 are meant to be just for prototyping and releasing and testing of new features. And then every 4th release is the one where they really put their stake in the ground and say, this is the version that we're going to support for a significant period of time, whether that be 4 or 5 years. And so if you're looking to install Ubuntu and you're not sure which version to use, most guys would recognize, unless there happens to be a very particular feature that was released in 2023 or let's say 2025 that you absolutely need, stick with the most recent LTS long-term support release of it. And so you see the numberings that look like that. So it's numbered by year. So that's 2014. .04 is the month, so released in April of that month. So you see your releases in April and October, roughly, of every given year, with those interim or standard releases every 6 months in between here. It depends on what your needs are, but it's pretty common to then want to just use the long-term support. If it's for your own laptop, you don't want to think about it for a couple of years. You want to just go for the standard kind of patching and update path. That would be the one you would typically want to use. On the flip side, you have the numbering scheme, which I think is relatively straightforward. So 24.10, as the name kind of implies, was released last month. But the most recent long-term service was released this past April. And they have both kind of historical releases as well as projected future releases, and you can look at them there. This one is just the listing of all the LTS ones. They decided, based on the FAQ and my own interpretation of it, they decided as a joke to make one of their early releases and to name it with an adjective and an animal that had the same first letter, and then they decided to stick with it. So if we wanted to predict, we are currently on the most recent standard release, Oracular Oriole. I think they're running out of adjectives and animals. You can't quite tell here, but every 6-month release is just incrementing. The next one will start with a P. Whether you need to know the numbering scheme or the code name or not, that's kind of a unique sort of Ubuntuism that they all have that kind of odd name, and some people like to refer to the code name and not the version. But in general, you can tell which release it is based on the numbering scheme. What year, then what month. Yeah, sure.
Are they skipping certain letters because there's no Y or A or Z?
So there is, you just can't see it. So, okay, good question, thank you. So I don't remember what the Y, Z, and A would be, something silly. I don't even know what xenial means or what a xeris is. That's your task to look up what a xeris is after this. There's 3 releases not shown here because they're standard releases. They're supported for that 6 months, and then they're kind of, you use it if you absolutely need to. Some obscure software packages will pin themselves to a particular version of a distribution, but that would be very bad practice to pin it to a standard version that's going to be not supported in 6 months. So in between that, there was a, where are we at? 16.10, which was Y, a 1704 that was Z, and a 1710 that was A, and then that's why it looks like it's skipping a few letters each time here. Now you've since looked it up. What is a xenial xeris? A xeris is a ground squirrel. What does xenial mean? I don't even know if I'm pronouncing it correctly. Xenial? I don't know. A hospitable ground squirrel. Okay, I'll give it. I feel like they're running out of adjectives because actually I don't know what a focal fossa is either, or noble numbat. Okay, fine. Oracular oriole. Um, there's an interesting kind of small caveat here that is worth discussing briefly. Um, as part of that guarantee of relative stability, right? You install 2204, you get those 5 years of support. It's meant to be a primarily stable release where it's not going to break your applications on you just because you did an update of some other built-in packages here. So for that reason, many of these distributions intentionally will not actually increment the package until the next major release. That makes it a little bit harder to kind of keep track of, depending on which distribution you're using, actually particularly which version of a major piece of software you're actually using. My numbers are actually a little out of date here, but the concept still applies, so I wouldn't worry too much about it. Just as an example, and don't call me on the particular numbers here, Apache 2, right, major web server, open source web server software, was version 2.4.38 when Debian 10 was released back in 2019, which from a software security point of view, from a web server's perspective, is ancient history, right? Today, and again, I don't think those numbers are correct, but they're close enough to correct, it is still that version. If you were to look at that Debian 10 release that is still being supported, it still has version 2.4.38. I ask rhetorically, how is Apache 2 version 2.4.38 doing now? And we'll get back to my point here. You go to the Apache server project, you look at their listing of their own vulnerabilities, and well, it's a web server. I talked about web browsers being a pretty prime target. Certainly web servers are also a very, very prime target. And 2.4, not to say at all that it's a bad piece of software, but it has been very thoroughly explored and lots of people having eyes on the source code for it. And there's all sorts of, amongst other things, remote code execution and other vulnerabilities of the type we did talk about when we talked a little bit about web application security. So if nothing else, you should see some of the terminology we looked at when we were talking about that particular topic here. There's a whole bunch one. So improper escaping of output in mod rewrite, which just allows you to change what directory things are being served at, allows an attacker to map URLs to file systems locations that are permitted to be served by the server, but are not intentionally directly reachable by any URL, resulting in code execution or source code disclosure. We looked at that one, and it was one of those things that we looked at and said, well, why would I ever allow my software to do that? But that's with the knowledge of our current day, right? Understanding that we want to prevent people from doing directory traversal attacks. Turns out it's not as straightforward as it sounds to implement protections against that in every possible circumstance. I guarantee you this version of Apache was preventing the very straightforward versions of those directory traversal attacks. This particular module that has some particular directory traversing needs as part of it had some particular vulnerability. I think I have it here. This particular CVE, it's just a directory traversal attack here, which you tend to know when you have them, when you see lots of backslashes in the URLs that it is hosting here. This one is up on GitHub, so again, we're talking ancient history. This is still 2 years after the release of that version of Debian, that version of Apache here. And all it's doing is checking whether or not a particular web server is vulnerable to this particular CVE. And what is it doing? I think we could kind of figure it out. HTTP plus whatever IP address plus whatever CGI server directory things are being loaded out of. %2e is what is 2e in ASCII? Just period. So // / /etc/password. So that seems very blatant. This particular version of Apache that was in use was vulnerable to something that seems pretty straightforward to us now looking at the exploit. Wasn't obvious until the CVE was disclosed and until patches were provided for it. What is the point of this though? So if we look at that particular version, which was released, and it is still on that version, I think raises two resulting questions. First off, we already kind of covered, but I want to make sure we understand it. Why would Debian be purposefully slow in adapting new versions? Debian 10, there's been many new versions of Apache 2 since this version. Why would intentionally they be slow in adopting new versions? Not quite, unless I misunderstood you. Part of it is the whole idea of why we have this. This is Ubuntu. I'm switching back and forth between Debian. I install whatever, 2004.lts, focal fossa, and part of what I'm getting as part of that arrangement, that relationship, is stability. I'm getting a version of the software, the operating system, that is going to, if it works today for my purposes, it should work, I think, up to 5 years from now for my purposes. And things like doing a major update of a web server in that system is very likely to break stuff here. But now we have kind of conflicting needs here, right? The needs of stability and security are at least ostensibly in conflict here. So that is another sort of rhetorical question. Is Debian's version of Apache on Debian 10, is it wildly insecure? The answer is no. Now, how we go about doing that is following sort of a well-known practice referred to as backporting. This also breaks the kind of nice, clean, sort of semantic versioning view of the software that we use, but it's kind of necessary because we really can't have both. You can't have a stable version of an operating system in which there's certain guarantees of functionality not breaking, and then have fixes for vulnerabilities that are discovered well after the fact of the release of that particular software. So it is something akin to a hot fix or a targeted micro patch, mostly for security vulnerabilities in mind. And this is what the people, the developers as part of the Debian project or the Canonical, the Ubuntu team are doing, and that's why they have so many software engineers, is to look at what fixes are feasible and to port them backwards to the older, stable, supported versions of the software like Apache and like all the different packages that they're expected to support. So as a highly simplified example, if we have a version, most recent version of a server or software has a buffer overflow vulnerability, the version that we are then supporting as part of the LTS has that same vulnerabilities. The developers, as part of that team, they're not just packaging binaries together, they're trying to determine for a particular suite of vulnerabilities, can I take the most recent updates to that piece of software and just add those back in to the older version of the software? That might be a straightforward task. It might be such an obvious vulnerability that the fix is a one-line fix. It might require some significant development effort to kind of backport those patches to an older version of the software. It's not always possible. So I mentioned this practice is backporting. You can't always do it. The vulnerability could be so fundamental to some piece of functionality that difficult decisions have to be made, and we have to say, well, you wanted this nice stable version, we actually can't support it anymore. You have to update it if you want to be protected from this particular exploit here. So what you will then see is, yes, Debian 10 is running that older version of Apache 2, but not really, I guess, can be your takeaway, right? What is the actual version? The version we talked about that has all those vulnerabilities, now in our versioning guide, plus those particular OS distribution specific backported patches that are there to prevent against those CVEs. So it's not as straightforward as saying Apache is vulnerable, I need to update to the latest and greatest version of it. If that's going to break things, I'm on this LTS version of the operating system for that exact reason, because I want the stability guarantees of not having to break everything every 6 months with my software here. This kind of middle ground is referred to as backporting. Fixing software while not necessarily following the traditional software development flow for that particular piece of software. Taking the fix, but not the new features that potentially are going hand in hand with the fix. And so you tend to look at the packages you're installing, are the semantically versioned ones, plus all the other fixes that were typically for security reasons. Again, that backporting fix could be very straightforward. I have a buffer overflow vulnerability. I just need to check that I don't do that, that I check the range of the array that I'm accessing. Sometimes it's more complicated. Well, it turns out the code only worked because I was overflowing that buffer. Now I need to re-engineer this whole entire function. Now you need actual software engineers as part of the Debian team to release that backported fix. Or there's a fundamental flaw in how this module is designed. It is very difficult to have the functionality of that module as well as the prevention against the exploits that are being developed for it. Now we have to have some difficult discussions of whether the fix can be backported. It would have to be back because there would be as we see, there's a number of the LTS versions. This one's old in the sense that I don't know what legacy support really means for the Ubuntu world, but otherwise that's roughly up to date in terms of what is still being provided with occasional periodic security maintenances. Presumably for something as important as Apache, I'm just saying that I don't know that for a fact, you have these 6 different LTS versions, they would have 6 different major versions of Apache associated with it. And so when there's a big vulnerability, and if it does go all the way back, and it sometimes does, right? If it's discovered in 2024 in this version, there's a likelihood it's also vulnerable in all those prior versions. You would have 6 different backporting tasks associated with getting that to work, plus whatever intermediate releases are still being supported. That's why, running a company that does Linux distributions is not as straightforward maybe as it sounds, right? It's not as simple as just take all this open source, package it up, and ship it out. It's the support aspect of it that makes it kind of a non-trivial sort of task here. That is just kind of the final aspect of remediation. And this doesn't come up in the lab because it's intentionally designed not to do so. But when you do have those things where the mapping between the version number that's provided and actual what software it's running isn't always that straightforward. So when you have those backported fixes, that can very much confuse the kind of software we use to scan for those vulnerabilities. Because if it's not hyper aware of what particular backported fixes are in place, it may miss the fact that while it thinks it might be vulnerable, it in fact has been patched against that particular vulnerability. 2.4.38 itself might be vulnerable, but 2.4.38 with those backported fixes is in fact not vulnerable here. Let's keep moving. Not that we're behind. Again, this is all optional. But let's kind of do a quick switch of context here. I thought this topic was, as an optional topic, still kind of an important one, so that we can all gain, I think, a better fluency in the primary terminology used when discussing software exploits, malware in general. Now, this should get covered in 230 or 2300 as well. So we'll see as we go through this how much of this is kind of repeat topic, which is also fine, and how much of this is new to you. So expect to hear this question a few times today and on Thursday. Did you guys already hear this before? And that's okay if you have. I just want to kind of ping you periodically to make sure that we're not completely treading over old ground here. Part of what makes it interesting is that it's not standardized like the way our CVEs, CWEs are roughly standardized. So you have this terminology, and it's a much looser type of terminology. So this is just one version of the terminology that we'll just kind of understand and explore, and so be it. And you may find other definitions elsewhere, but I think you'll be able to map what you read elsewhere onto what you're learning in this particular course. To start with the definition, malware, malicious software, anything that threatens confidentiality, integrity, or availability. For the most part, what we've been doing this semester has just been sort of stopping at generating a login or generating a reverse shell, which is sufficient, right? The whole point is once you have that level of access to a system, the game's afoot. You're up to do all sorts of other things, but for our proof of concept, we've kind of considered that to be sufficient. We will talk about all the other things that a software attack can potentially accomplish and what mechanisms they use to accomplish those things. This is in your textbook. In lab, you're continuing on your final project. How's it going so far in the final project? There was some discussion last week where there was more exploitable things than what Lab 11 said to look at. And the question was asked in such a way, are we in trouble if we look at those other machines? No, you're not in any trouble. It was just meant as a way to kind of split up the work into Lab 11 and then separately Lab 12. So you'll see these other boxes here. that aren't part of the Lab 11's statement of work. You won't break or harm, or you won't get in trouble for looking at those machines as well. But take note of it. Wait until next week to look into, or once you're done with Lab 11, to look into those other boxes. That kind of gives you the preview of what Lab 12 will be about, just sort of continuation of the same thing. And I think we know this because we've been looking at the schedule periodically all semester long. That final Thursday class of the semester, once we get ourselves back from break, we have a week, then we have dead week. That final Thursday, that'll be our MQ Charlie. Should also be no surprises on that one as well. Okay, let's talk malware. And we won't talk much about it today, but we'll continue on this on Thursday. Portmanteau, originally of malicious software. Now I think it's effectively a word in its own right. Any program designed to do bad stuff is a pretty good working definition. Anything that's going to cause damage by using compute, giving additional unintended access by bypassing access controls, or just anything that's sort of leaking information. So our confidentiality, integrity, and availability. There's many different categories, and terminology is somewhat loose. Some of which we've already used these terms, so there's only a few of these that are terms that we have not used so far this semester. We'll talk about and be a little bit more precise with our definitions for those particular terms. And I think afterwards you'll have gained a little bit more fluency when talking about different classes of malware. Here's a very brief historical timeline. This is my own timeline. There's many other timelines people could create. Start with 1949, John von Neumann. Does anyone know who John von Neumann is? That's okay. There's a Wikipedia link there. I recommend you all take a look after class is over. Possibly, the greatest mind of the 20th century, or he's certainly on the list. One of his many, lectures, papers, on the concept of self-replicating automata. So this idea that software can beget other software wasn't really a well understood concept, and this is the very, very early days of computing as we know it today here. So I'll put that as sort of an early milestone of malware. The idea that software itself can self-replicate was not an understood concept. We kind of connected to the sci-fi world. Michael Crichton, his 1970s movies, Westworld, not the re-released television show of the same name, very, very loosely related. Sort of the first, or very close to the first that I could find, mention of the term virus to refer not to just the biological aspect, but the computing analogy there, which is self-propagating malicious software. This is the earliest reference I can really find in any common use where it was just not the biological concept of a virus, where it's self-replicating, but software itself acting in the nature of a virus. That's 1973. Still, you can call it early days of computing, but as we move on, a very seminal paper by Ken Thompson, Reflections on Trusting Trust. Here's another time where I'll ask the class, have you seen this paper before? This is not a class where I ask you to read lots of papers, but this one's very readable. Have you seen it before? In 230, did that paper come up? I would be doing a disservice if I don't bring it up now. So this was a lecture that was just committed to a paper. But if we take a look at, there's John von Neumann, but here's Reflections on Trusting Trust. And it's related to malware in a sense. To what extent should one trust a statement that a program is free of Trojan horses? It turns out that is a much more difficult problem than it appears at first glance. Now, this is an older academic paper. This was the year that he won the Turing Award, but he's talking about a time roughly a generation before that. And Ken Thompson, Dennis Ritchie, the original Unix guys, the original C programming language guys. He's also the original Golang guy as well. So it's all related to that world that we kind of keep jumping back into this semester. So he first talks about in this paper, and I don't ask you to read a lot of papers this semester. Zero, I think this is a 3-page paper, so you can actually go in and read it. It's not something that's going to stress you out and be way too much of a time commitment here. He talks about the issue of trust in software, but from there he actually starts about how do we actually build software, compile software in a way that we can actually rely on the end results of what the compiler is generating. Reflections on Trusting Trust. Another way to think about this is his reflections on actually compiling compilers. we still have this as kind of a fundamental issue today, right? We have a piece of C code we want to compile for our system. We're writing an updated patch to Apache, and we want to compile that C code or C++ code in our system. To do so, we are reliant on the compiler installed in our system to generate that binary artifact. But from where do we get the trust that the compiler is doing what we expect it to do and not itself acting in a malicious way? Well, we have a piece of software that was the compiler. Somebody then compiled that source code to generate the compiler, which then is used to compile other software. Okay? Who then has the trust in that first compiler that's used to compiler, the second compiler, which is used to compile the software that we use? The concept in the compiler world is referred to as bootstrapping. Where do we start with to get an open source compiler? This was something that people kind of stressed about in early days. Do we do some sort of binary hand-coded compiler to generate a very tiny compiler to generate a more complicated compiler? When you install GCC, it does still attempt to bootstrap itself in such a way. If you use other compiler infrastructures, they just say, as long as it passes our tests, it's good enough, and that may be good enough. So this example he's talking about in this lecture, this paper, that one of the things he used to have fun doing as an early programmer was to write sort of self-replicating programs. A program then, when compiled and executed, would print out its own source code, which is something that's not as straightforward as it seems, because we have these other components in the source code that are there to support things like printing things out, and there's a redundancy issue there, or a not chicken and egg, but who is building this, which is building that, a recursion issue with regards to that. So in this paper, he talks about a little bit about the kind of techniques that can be used to write programs that print itself out that he used to do just for fun, and then what it would take to then add a new feature to the C programming language, for example. How to build a compiler. And there's all sorts of software, some of which this person himself wrote, to build compiler softwares. And he talks about how one could add a new special character. We have \n, how we would add a \v for a vertical space here. From there, he talks about, he's a little bit tongue-in-cheek. It's not that clear whether he actually did this in practice, but that in the early days of supporting Unix systems, they would actually patch the compiler itself to check that if the source code matched a particular pattern, to instead compile out a bug instead. Now, someone looking at the source code of the compiler would recognize there's an issue there, but what he talks about how is, in that compiler, the source code would be obvious, but if we put instead the Trojan horse in the compiler that was to compile that compiler that would then compile the source code, it'd be very hard to detect that that was the case. It'd be very hard to detect that the Trojan horse was actually bootstrapping itself into the application of those software. So he talks about it here where the Trojan horse they installed was in the actual login command. His C compiler in his Unix system would be bootstrapped to insert a vulnerability in that command that would accept either the intended password or a particular hard-coded backdoor password into the system. Did he actually do that or not is not that clear to me. Maybe as you read the paper on your own, you can discover whether he did that or not. But in those early days of having to support Unix systems, it might have been very valuable for him to be able to remotely access any of these computers in the world to determine what else was happening with that particular computer and to fix those problems as they would arise. That's your unofficial homework between now and Thursday. Let's leave things here for today. We'll pick up right here after our quiz on Thursday.